Okay guys, here we are in Unit 9. So this one we're going to be getting into the weld and welding symbols. This one specifically is going to be going over fillet weld symbols and the welding symbol as a whole. So this stuff is pretty useful. Um, what we went over in the previous units was the joint types. Okay, so we should know the 5 basic joint types. You've got your T-joint, your lap joint, your butt joint, your corner joint, and your edge joint. What makes a joint skewed? So if it is a T-joint or a corner joint, anything off of 90 degrees is going to make it skewed. And for a butt joint, anything off of 180 degrees of each other is going to make that skewed. And then can you have more than just a fillet weld inside a T-joint? Yes, that depends on the prep of the plate. Okay, if a T-joint is put together and nothing is done, then yes, it would be a fillet weld. But if you put a bevel on something, well, now it's a single bevel. Okay, so remember that the joint type is not the same as the weld. Okay, so in this unit, we'll be going over the components of a welding symbol, what the difference is between equal leg and unequal leg fillet welding sizes, interpret fillet weld size and extent from a welding symbol, to interpret and explain the variations in intermittent fillet welds from welding symbol information, and then relate weld contour and finish weld symbol information, and how that incorporates into the welding appearance, the final kind of product. Okay, so the welding symbol. So AWS, American Welding Society, they're the ones that have kind of come up with the standard on all of this. Okay, so just remember that you have a weld symbol and a welding symbol. The weld symbol is the drawn shape representing a specific type of weld. So a fillet weld or a groove weld or one of the many different types of groove welds are all going to have a specific, almost looks like a hieroglyph, denoting that type of weld. The welding symbol provides a complete set of welding instructions, including the location of the weld. All right, so this is where all the information is. All right, majority of the U.S. welding industry uses the AWS symbols. Outside of our borders, though, you have the ISO standard or the IIW symbols. So ISO, that would be like your, a lot of countries that use the metric system use this as well. And then some shops even create their own if they have some sort of proprietary processes or designs, things like that. They might come up with their own symbol so that it's more difficult for people to copy, or maybe they just want to be custom. Okay, so this whole thing is the welding symbol. Okay, the primary component of the welding symbol is the arrow, the reference line, which is just this horizontal black line, and the tail. Okay, so those 3 things are like the primary components, and the arrow can be on either side. So depending on the print, the shop drawing, it may be more convenient for the arrow to be pointing off the left side versus the right side. But no matter what side the arrow is on, all this information on the reference line stays the same. Okay, nothing swaps here. Okay, so the arrow element, that tells you where, okay, that's going to be pointing where the weld is going to go. The reference line is going to have all the instruction for the weld, and then that tail is going to be for specification process or any other sort of reference. Okay, and if there's no information that needs or wants to be put in there, then you can omit the tails. You don't have to have the tail. But if you need a note, like maybe this is going to be a GTAW weld, and we want to denote that it needs to be that process, and maybe we want to put in there the specific material, right, for the filler rod. Maybe we don't want to use LN56, maybe we want to use a different grade and specify that. Okay, so that's what the tail would be for. So on the reference line, your weld symbol would be right here between these parentheses, okay? And we have a top and a bottom. So right here you're looking, if my weld symbol is on the bottom, that means arrow side, and if my weld symbol is on the top, that means other side. So that means where this arrow is pointing, if my weld symbol is on the bottom it's going to be right here. Imagine there's a T-joint, and this is pointing right in the corner. Okay, that's telling me I'm putting my weld on this side of the T-joint. If the weld symbol was on the other side, the top side, that's telling me it would go on the other side of the T-joint. Okay, and then if you had the symbol both sides, then that just means both sides. And we'll go through all the different types of weld symbols, but this is where it would be located. So on the top side above the weld symbol, if this was a groove weld, maybe this isn't a fillet weld, maybe this is a bevel or a V groove, okay? Above it would be the root opening, so that's again just that gap between the two materials. So the R right here would be the root opening, and then you'd have your groove angle. Okay, so that would be telling you what the included angle is, so the whole groove opening, not just the bevel. And then the contour symbol, so do we want a flat weld, a convex weld, or a concave weld? That's where that would go. And then at the very tippy top would be the finish symbol. So are we grinding, brushing, machining? Okay, what needs to be done after the weld, if anything? All right, and obviously if there is no, right, if this was a fillet weld symbol, then we wouldn't have the root opening. Okay, so it's not always going to be there. It's only going to be there if it needs to be there. So back to the weld symbol right here in the center, to the right. Okay, again, no matter which side the arrow's on, to the right of the weld symbol, first is going to be the length of the weld. Okay, so how long is that weld going to be? And then to the right of that is going to be the pitch. Okay, and just keep that in mind for intermittent welds. Okay, that's what that is talking about. So just keep that in mind. That goes to the right, and we'll talk about pitch in a later slide here. To the left of the weld symbol, you're going to have groove weld size, if it's a groove weld. The weld size, okay, so if we wanted a 1/4 inch wide weld, we would put 1/4 inch here. If we needed a 3" or a 3/8 wide weld, we would put 3/8 here, okay? And then to the farthest left, the depth of groove. Again, only if it's a groove weld. Okay, and then on the bottom, all you ever get is the weld symbol. All right, so it should be pretty easy to remember. Just quickly, briefly going over this again. Arrow element is where the weld is going to be. The reference line has all the prep and instruction for the type of the weld, and then extra information specification would go here in the tell. These two symbols over here, okay, if you see this circle, that's telling you to weld all around. So think about like a pipe to plate weld. You're welding all around. So if you see this on the print, whether it's a pipe or a T-joint, if you see this circle at the bend here, that's telling you you need to weld that thing all the way around. And then this field weld symbol, this flag right here, that's telling you that this weld that we're talking about on this welding symbol, that gets done out in the field, not in the shop. Okay, so maybe this is a pre-assembled structure and it's going out, and certain welds will be done in shop. Maybe they're building frames and floors and vertical pillars and stuff like that. But then a lot more of it gets fabricated and welded out in the field. So if this specific weld was one of those welds getting done out in the field, you would see this symbol here. Okay, so that's kind of the breakdown of the welding symbol. So the basic component, again, arrow, where that weld's going to go, the reference line, this is the horizontal line, and then the weld symbol. And this is a fillet weld symbol, kind of a triangle. All right, two sides, again, if we're on the top, what is that telling you? All right, that's going to be other side. So other side would mean the arrow's here, other side. Okay, so my fillet weld would go over here. And then bottom would be arrow side. So if the fillet weld symbol is here, I'd be laying it in right where that arrow is. Okay, and this is a fillet weld. Okay, so a fillet weld is a weld that you're putting into a 90-degree corner. Okay, the goal is basically you're just trying to make a triangle, a structural shape out of all of this. All right, and just like we talked about in the previous unit, if it was off 90 degrees at all, it would be a skewed T-joint, but it would still be considered a fillet weld. Okay, so the size of fillet welds, when we say we want like a 1/4 inch fillet weld, we're not talking about 1/4 inch measured across the face of the weld. Okay, fillet welds are measured by their leg length, so it would be 1/4 inch this way and a 1/4 inch this way. So that would actually yield a face longer than a 1/4 inch. Okay, so don't go off the face measurement when we tell you we want a 1/4 inch weld or a 3/8 weld. It's that we're talking about the leg lengths. So if you measured your T-joint, put like a soapstone, boom, 3/8 here, and then measure this way and 3/8 here, that's where your toes should be meeting. Okay, so that's what the leg is. Okay, this measurement right here, from the toe to the root, basically, both sides. And with T-joints with fillet welds, 99% of the time you're wanting equal leg lengths. Okay, very rarely does something call for unequal leg length. So keep that in mind when you're welding. That's one of the things I get pickiest with about my students, is making sure we have equal leg lengths, because that keeps that structural shape, the symmetry, and that's that's going to be the best way to weld. That gives it the most structural rigidity. Okay, over here we've got some more technical information for the weld profile. So from the face of the weld to the farthest point of penetration in the root is called the actual throat. So that's basically the widest point between the cross section of your weld material. Okay, the effective throat, you're going to take a cut across the shortest distance from toe to toe. Okay, so you could see if this was a perfect triangle, it would lay right here. This kind of convex profile is a little bit of added material, but this is the effective throat. Okay, and that's to the root where the two pieces of material would have met. Okay, so that's called the effective throat. And then the theoretical throat is from that mark to where the effective throat is from the greatest distance of penetration to the line between the toes. The theoretical throat goes to where the material first intersected. Okay, so actual throat, effective throat, and theoretical throat. And then this is your reinforcement. That's the convexity of the weld. Okay, so the amount of convexity allowed depends on the width of the fillet and weld face, and depends on the code itself, really. Weld toes located at point. Weld toes located at the point. What kind of typo garbage is that? Okay, at the edges of the weld, where the weld washes in to face of base metal. Okay, so that's a bunch of weirdly worded ways of saying the toes of the weld are where the weld material meets the base material. Okay, a lot of people call it the edges of the weld. Technical term is the toe of the weld, where the weld material meets the base material. And then the theoretical toes. So in theory, where the toes of the weld will be after welding is completed. So that's just you're calling for a 1/4 inch fillet weld. There's the theoretical toe. That's where it should be. If you measure that T-joint at 1/4 inch on the vertical plate and a 1/4 inch on the horizontal plate, that would be your theoretical toe. But your actual toe is going to be what it winds up with. Okay, so the throat extends from the root of the weld towards the face at an angle that bisects the angle of the joint. So coming straight out of that corner at a 45-degree angle. Before welding begins, the throat is referred to as the theoretical throat, just like the theoretical toes. Okay, so we know where the throat is supposed to be, and then after you weld it, you get the actual throat. Okay, So the effective throat is determined by the distance from the root of the weld to where the imaginary line drawn from one toe to the other is. Okay, so this is the effective strength of the fillet weld. All right, this is limited to the distance of effective throat. So that's the effective throat is kind of their strength indicator. And then the convexity of the fillet weld does not increase effective strength of the fillet weld. Okay, so here is a single fillet weld. This is that fillet weld symbol, that triangle. So a single fillet weld would just be one on either side of this line, and then a double obviously would be both. And the vertical line is always to the left of the horizontal. Okay, you would never have the horizontal coming down behind. All right, the horizontal is to the right, the vertical is to the left. Okay, so this is what arrow side fillet weld would look like after the weld. Okay, so your assignment this week is going to be looking at symbols like this and or images like this, and then putting the weld symbol on the correct side of the reference line. So pay attention. So arrow side, right, is going to be on the bottom, so it's going right where the arrow is. Other side, it's going to the opposite, both sides. Again, the vertical line is centered, the slanted line is to the right, and that's going to be a weld on both sides. And here's that same example just on a lap joint. Okay, most joints have two sides to them, so that's why we always have that opposite. So fillet weld size, again, measured by the leg lengths. In the example on the left, the weld is an equal leg fillet weld with each leg 1/4 inch long. So again, to the left of that weld symbol, looking at the welding symbol, remember in that reference page, to the left, this isn't a groove weld, so the only thing here is going to be the weld size. And we want a 1/4 inch weld, so we want 1/4 inch leg lengths. Same thing, but with a double fillet. All right, equal leg lengths, equal leg lengths. If the fillet weld size is absent from the symbol, you can review the general notes. They might just have a typical or all welds on this project are the same size, so just declare it there so we're not taking up space on all the welding symbols. So if it's not out there, then you can refer to the general notes. Often used to join two plates of different thicknesses. All right, T-joints, typically unequal leg fillet welds. Usually the longer weld leg is placed on the thicker plate to put more material into that one, right? So if this bottom plate was thicker, we would want to skew it a bit, and so we would get a little more penetration into the thicker plate. Okay, but again, that's pretty rare. And then typical. So when you see typical, again, in that tell where references are, typical, TYP, 4 places, that's going to tell you for all of these, it's going to be the same double fillet weld. That way you don't have a weld symbol on every single one of them. So that's what typical is telling you. And again, this is just another way to kind of save space. So weld length. Okay, remember that would be to the right of the weld symbol, that fillet weld symbol. So fabrication doesn't always require welds the full length of the joint. The engineer determines the amount of fillet welds needed to obtain structural integrity, and sometimes that is a full weld, sometimes it's an intermittent weld. Okay, sometimes it's just in a few strategic spots. That's completely up to the kind of design and the intent. Welding symbols specify the required amount of fillet weld on the joint. Okay, so depending on the weld process and the joint thickness and the material itself, we might need a 1/4 inch weld, or we might need a 20 pass of 1/4 inch welds, or we might need to go to a different process and get a triple pass with 1/2 inch wide welds. Okay, so it just depends on the intent. Okay, so there are 3 methods of reducing weld length. expressed differently on welding symbols. The first one is going to be identify the length of the fillet weld on the welding symbol. Okay, so 12-inch long. Okay, we need a 12-inch long weld. So if we did not need to go full edge to edge, the print called for a 12-inch weld in a T-joint in a fillet weld right here, by default you would just kind of center it. Okay, so that's kind of like the default response is to center. So you would measure it, and then you would split the difference. Right here, this is telling us we want 3 inches off this left side, and then our 12-inch weld. Okay. The second method of specifying weld length. All right. So the length of the fillet weld specified with the extension and dimension lines. Boom, boom. The weld length doesn't appear on the welding symbol. Okay, so we already know what the dimensions are between the edge of the plate and the beginning of the weld, so we don't need to have the length of the weld also right next to the welding symbol. So multiple arrows drawn from one reference line, each pointing to a location of a fillet weld. So this is another way. So this maybe you're welding 3 of 4 sides of square tubing. You don't want to use that weld all around symbol. So you're denoting this side, and this side all get this weld. So intermittent fillet welds, okay, also known as staggered welding. This is the third method of specifying weld length, also known as stitch welding. Okay, this just uses a series of short welds of equal length, equally spaced regularly on a joint. So each intermittent weld referred to as an increment, and then the spacing is referred to as the pitch. So remember, back at that slide of the welding symbol, the whole welding symbol, I told you to remember that one of the pieces of information to the right of the weld symbol could be pitch. So this is where we're going to get into that. So just remember, each intermittent weld is referred to as an increment, and the spacing is the pitch. Okay, so there are 3 variations. Intermittent welding is on one side only. Okay, so 1/4 inch fillet weld 2-5. Okay, so it's a 2-inch weld. Is that our increment? Okay, and then 5 inches on center, pitched. All right, so the first letter is going to be the length of the weld, and then the second letter is going to be the pitch. All right, that is the distance between welds, but it is going by the center of the weld. So this is a 2-inch weld pitched at 5 inches. So you're going to have a 1 inch this way, 1 inch this way. So that will leave you with a 3-inch gap between the welds. Okay, but that's how you measure the intermittent welds. The pitch of the welds is the center of those welds. Okay, so continuous fillet weld on one side, right? So a 5/16 fillet weld all the way the length of that weld joint. And then on the arrow side, we've got a 1/4 inch weld, 3 inches long, pitched at 7 inches. Okay. So here we've got a chain intermittent weld. So that would look like this. Fillet weld symbol, 3-inch welds, pitched at 6 inches. Okay, uniform. So the welds should be measured off the same edge and symmetrical on both sides of the T-joint. A staggered intermittent weld, okay, would look like this. They look offset on that reference line, and that's going to tell you that we want to split them or offshoot them by half of whatever the measurement is. So we're at a 3-inch weld with a 10-inch pitch. So my weld is 3 inches and the pitch is 10. So between the welds on this side, they're 10 inches spaced centered. But if we measured this weld to the weld on the other side, they would be centered 5, so half. That way it gives you the staggered look. So So a chain intermittent, same increment, same pitch, placed opposite each other, uniform. And then a staggered intermittent weld, uh, intermittent on each side of the joint, but the fillet welds are not placed opposite. Okay, so they're offset. Offset. All right. So it looks the same, just kind of, again, offset on the reference line. So easy to remember that they should be offset on the plate. Okay, so obviously on a staggered intermittent weld, the layout is going to be a lot more involved. It's going to be a little trickier because now you've got to deal with kind of making sure you're staying mathematically accurate on both sides as you're going. So it takes a little more prep work. Usually when you're doing stuff like this, you'll lay it out and then tack the beginning and end of the weld, beginning and end. And so you've got all your 2-inch or whatever, right? These are 3-inch, so you would have a tack 3 inches apart wherever those welds are going to lay. That way you could just then drop your hood and just burn all those segments between the tack welds in. Okay, so when specified on a joint, both ends typically get welded with fillet welds at the specified length. Okay, so 1/4-inch fillet welds, 4 inches long. So if it's not denoted, right, then it's just going to be off the edges. Okay, but right here we've got it 4 inches, 4 inches, and so we're being told to go off the edge. So again, multiple arrows can be used, just like we saw in that one that was getting those 3 edges done. It just depends on what detail needs to be conveyed to the reader. So weld contour symbols. So again, the contour, that's just going to be like your convex. So that's a natural shape produced by most welding processes and filler metals. That's your small little speed bump of a weld, slight buildup. Concave, so just easy to remember, it's a cave. So it's kind of sunken in, it's caving in. So concave, that would be like a lack of reinforcement or lack of material. And then flat, so just a straight line, parallel to the long side of the fillet weld, and a short straight line placed parallel to long. Man, gotta come in and fix some of these descriptions. I feel like we're missing words. All right, so just flat toe to toe. All right, and that's what this symbol would look like. So convex, again, just looks like the contour we're looking for. So this is the weld symbol, a fillet weld, right? A triangle, that's what we're trying to make inside that 90-degree corner. And we want a convex, a slight buildup. Concave, sunken in. And then flat, just equal toe to toe. Okay, and then lastly we have our weld finishing methods. So remember, if it wasn't a groove weld and we didn't need all that groove opening information, bevel information, then the next spot would be for the finish symbol. So we have G for grinding, M for machining. So maybe it's a surface weld that needs to go and get machined down. Chipping, so just chipping off slag. Peening for heat treating. Rolling, hammering, or unspecified. Okay, so that's the symbol. It's just the first letter of the word. All right, man. I know this was a long one, so thanks for sticking through, but the weld symbols is very important, very useful information for you to know, especially if you're going into the structural welding world. So good information to keep on hand. We'll see you guys in the next one.